Myron.
And I'm Ryan.
And this is our Lab 10 report on semiconductor light sources with Harsha Pradeep as our TA. To give an overview of experiments, in Part A, we measured the physical properties of laser diodes and LEDs. In Part B, we recorded the spectrum. In Part C, we recorded the beam divergence. And in Part D, we recorded the power output versus drive current of LEDs and laser diodes. So in Part A, we used a camera and microscope to measure the physical properties and cavity length of them by first using a ruler to calculate the number of pixels per millimeter, which then we could convert pixels to millimeters. So for the red LED, we measured the cavity length to be 0.85 millimeters, the green to be 0.89, blue to be 0.84, and the laser diode to be 0.86. The physical emission areas were then for red 0.7 millimeters squared, green 0.792, and blue 0.7. And we calculated the longitudinal mode spacing using the formula C over 2nL to be 50 gigahertz. These are some photos from the experiment, and comparing our values to theoretical values, the mode spacing was along the same order of magnitude. And then for the emission areas, they all fell within the relative range from 0.1 to 1 millimeter squared. In Part B, we used Thorlab's optical spectrum analyzer to measure the output spectrum of the laser diode versus drive current and observe the mode spacing below threshold, at, and above the threshold, and observe mode shift as drive current is increased. We calculated the mode spacing by taking the inverse of the distance between the peaks and multiplying by the speed of light to be 265 gigahertz, which is very close to the theoretical value and slightly higher than what we calculated in Part A.
Going into Part C is where we found the beam divergence of a laser diode and an LED. So here we use a detector, amplifier, and oscilloscope to measure the output, and then we use and then for each source we found the angular dependence to find the beam divergence, and in the end we used the polarizer to find the polarization ratios of each source. And so to begin with, the LED had a polarization ratio of 1.139 and the laser diode 3.25. And on the next slide here are all the graphs for power versus angle, the top graph being for the LED and the bottom two graphs for the laser diode, one for perpendicular to the major axis and the other for the parallel. And going into Part D, we found the power output versus drive current for the two sources, where we used the integrating sphere and a photodiode and varied the drive current from 0 to 40 milliamps in 4 milliamp steps, and to find the laser diode threshold, and then we plotted the power versus current for both sources. And then to summarize, some sources of error for each part include: for Part A, camera focus and pixel calibration; for Part B, spectrometer resolution and stray light from surrounding sources; Part C, misalignment of the laser and accurate angle readings, or as same for Part B, background light interference; and then Part D, stray light or misalignment between the source and the detector. And that's our report. Thank you for listening.